measuring some doing some measuring here. Now I tried to do some testing and troubleshooting on the board, but realistically you're not going to be able to measure the resistance or to see if anything's open, especially a transistor when it's on the board in a lot of cases. So you have to cut the transistor off the board anyway. So if you're doing this and you're not really tech savvy or don't know too much about electronics, you could get away with doing it. Just basically cut the transistors off and put in the new ones, and don't bother troubleshooting anything, because that's pretty much all you're going to do is remove transistors and install new ones. And I mean, you could test it with the meter just to see if it's different than the rest of them, but if that solves it, great. If it doesn't, then you just send the amp in to JL to get repaired anyway. That was pretty much what my mentality was when I was doing it. Okay, this isn't a lesson on transistors, but basically these are the ones that I pulled out. You have your gate, you have your drain, and you have your source. So testing them is kind of difficult to do when it's still on the board. You get kind of wacky readings and you don't really know if it's bad or good. So what I ended up doing is just cutting them off. I cut 8 of them off and tested them when they're off. I used a multimeter, just a standard one that I got off Amazon. It was like 50 bucks. I used that to measure basically between the source and the drain to see if there's any shorts. 3 of them were shorted, so I ended up replacing 8 of them, because when they're on the board it's hard to tell which ones failed and which ones not. So anyway, I ordered the new ones. This is the model here. Got these off Amazon, 10 of them for I think it was $9. So not bad. Not bad at all. And they come in this pack like this. Let's see if I can open it. I have 2 left, so I use 8 obviously. And then I have a bunch here that are still good. So I'm not sure what I'm going to do with them, but I might end up using them for something. Cut these off right at the base, and then there's still enough of a leg on there for me to grab some needle nose pliers and pull on it a little bit. And I pulled on it just slightly, and I came in from the bottom of the board, and I just touched the soldering iron to each of the legs as I'm pulling on it, and was able to pull each one out. I feel like that's introducing the minimal amount of heat into the board. I was able to do it like in a matter of 2 or 3 seconds, be able to pull the leg out. Then I came back with the solder sucker and just heated it up slightly with the iron and sucked out the solder out of each of the holes. And then I went in and stuck in the new transistors. So that's pretty straightforward. You've probably seen millions of videos on YouTube doing it, but I just wanted to let you know that it can be done on these JL high-end amps. Okay, so I replaced these MOSFETs back here. I basically just snipped the old ones off with a pair of dikes, or actually a pair of scissors to be honest. But yeah, I snipped the ends off. There was 2 of them that were bad, the rest of them were okay, but you can't test them on the circuit because they show up as open, even if they're good. So I took out 1, 2, 3, 4, 5, 6 of them. Went ahead and soldered in the new ones. Don't know if you can see. Didn't do a terrible job with the solder, actually. Not bad at all. For a beginner solderer. I mean, I'm not a professional at all, but didn't do a bad job. Real easy. I just used a regular soldering iron, nothing special. Just checked it, grounded out the ground wire, connected the positive, and also connected the remote. Saw that the power light came on. The yellow ohm light that was on before is it wasn't on all the board's channels. These are the 4 channels right here. All their lights were green. Nothing weird going on there. Next step, I should probably do like a full test, but I don't have the RCA to headphone jack connection, so I can't really play any audio. So I'm gonna basically put this amp back together and then try to test it out in the car real quick. So yep, that's the next step. So let's get this thing back together. I ended up not needing this solder sucker tape thing. Silicone. This thermal compound I'm gonna need. I'm gonna put brand new thermal compound. And one thing, I know everybody gives people shit for forgetting this, but I won't forget it. The insulators. I don't know what kind of plastic that is, but that's special plastic insulators. I won't forget to put those back on. Those are very important, so I'll make sure those get put back in place. And yeah, and I think we've solved it. So let's get this thing back together. So anybody that's having trouble with theirs and doesn't know what's wrong with it, it's hard to tell. This is the meter I used. It's hard to do, even in diode mode, it's hard to do it while it's on the board. I mean, while it's on the circuit. You pretty much have to remove it off the circuit to test it. And if you're going to remove it off the circuit, you might as well replace it at that point. If you're not comfortable doing it, don't do it, but it was actually surprisingly easy. So, worst case scenario, it doesn't do anything, it doesn't work, and you have to send it out to JL to get fixed anyway. So, it's always worth a shot. Alright, I'll get this thing back together and let's... Okay, the bottom of the amp's still off. So, you can see, bottom's still open. Do a quick test here. Worked before, but I added another transistor because I forgot to add it. I'm hoping it still works. Okay, just connected the negative, and now I'm connecting the signal. You can see ohm lights off.